Okay, we need to do some further work on indices. So I'm going to go through a few examples. You need to be quite proficient at manipulating indices. So the first one is these fractional powers. So we know that the nth root of a number can be written as a to the power of 1 over n, so it's one of the rules. But if we don't have a 1 on the numerator, so if we want to find, for example, 8 to the power of 2/3, then it's a slightly different method. So what you need to do is you need to bring this down first. So this is the same as having 8 to the power of 1/3 squared, because when you do a power to a power, you multiply. It's also the same as having 8 squared to the power of 1/3, but then you'd end up having to find the cube root of 64. So it's better to have a smaller number here, which you then raise to a power. So 8 to the power of 1/3 is the cube root of 8. None of these numbers are going to be that big, so this is kind of non-calculator work again. But if you literally like do 1 times 1 times 1, 2 times 2 times 2, oh yeah, that's 8. So just work through your integers. So cube root of 8 is 2, and 2 squared is equal to 4. If we've got a fraction, so say I've got 81 over 16 to the power of 3/4, we can do the same thing. So it's 81 over 16 to the power of 1/4, and then all of that needs to be cubed, so we get a bit of a double bracket going on there. You can split powers, top and bottom of a fraction, so that was another one of the rules. So a over b to the power n is a to the power n over b to the power n. So the fourth root of 81, 3 times 3 times 3 times 3 is 81. And the fourth root of 16 is 2. And so the fourth root of 81 over 16 is 3 over 2. And 3 over 2 cubed is equal to 3 cubed over 2 cubed. And then also bringing some negative powers into this. So if we've got 25 to the power of minus 3 over 2, remember if you've got x to the power of minus n, that's the same as 1 over x to the n. So the negative makes it 1 over. So this is the same as 1 over 25 to the power of 3 over 2. So that negative is just making it 1 over what you've got without the negative. And then 25 to the power of 3 over 2 will be the square root of 25 cubed, and the square root of 25 is 5, and 5 cubed is equal to 125. And then the fourth one, we've got 8 over 27 to the power of minus 2/3. So we've got a negative fraction and a fraction, which is as hard as they're going to go. So this is 1 over 8 over 27 to the power of 3 over 2, which is equal to 1 over, sorry, something gone wrong there, that should be 2 over 3. So the negative just makes it 1 over. 8 over 7 to the power of 2/3. I need to cube root top and bottom, which gives me 2 over 3. And then that needs squaring. And so here you get 1 over 2 squared over 3 squared. And when you have a fraction divided by a fraction, so I'm dividing by 9 over 4, you turn that around and multiply. So it's 1 times 9 over 4, which takes you to there. So the negative makes it 1 over power 2/3, like we saw up here. You cube root and then you square top and bottom, and then it's 1 divided by 4 over 9 essentially, which is 9 over 4. Right, second example. I want to simplify x squared times 3xy to the power 4 cubed. So if you're a bit unsure about this, there's a multiplication in there and there's multiplications between those. So here I can split this power across these multiplications. So I've got x squared, and then I want to cube each of these. So 3 cubed is 27. X cubed is just x cubed. Y to the power 4 cubed, you multiply those because you've got y to the power 4 cubed, and then just tidying that up a little bit. When you multiply, you add your powers. So that takes us to there. And then similarly, if you want to square root through things which are being multiplied together, you can just square root each section. So root 16 is 4. The square root of x to the power 4 is the same as x to the power 4 to the power of a half, and 4 times a half is 2, and 6 times a half is 3. Next one. Express 27 to the power of x plus 2 in the form 3 to the power y. So all this means is you want to write this as a power of 3. And we know that 3 times 3 times 3 is 27. So this is 3 cubed to the power of x plus 2. And then when you've got a power to a power, you multiply. So it's 3 to the power of 3x plus 6. And then just doing one more, I want to look at solving 4 to the x times 8 cubed equals the square root of 2. So we've got lots of different bases here. We've got 4, 8 and 2. And the trick with these questions is to get them all with the same base, and normally that would be like the lowest number that you can have as a base for each one. So I can write 4 as 2 squared and 8 as 2 cubed, and 2 is 2 to the power of a half. So 4 is 2 squared, 8 is 2 cubed, and that's equal to root 2, which is 2 to the power of a half. And then multiplying this out, we've got 2 I don't know if it's multiplying out particularly, multiplying these powers together. 2 times x is 2x times 3 times 3, 2 to the 9 equals 2 to the half. And then as long as the base is the same, you add the powers on multiplication. Which takes us to there. And now if you've got 2 to a power equals 2 to a power, then these two powers need to be the same. And so from here we know that 2x plus 9 is equal to a half, and then times things by 2, so we don't have to work with that fraction, and then subtracting 18 to get minus 17, and x is equal to negative 17 over 4, that's meant to say. Next say. So I think those examples should be enough. I've got these, which I think would be good for you to do to start with, which is just manipulating numbers to fractional powers. So do those first. I've put the answers underneath, which, yeah, I'd rather they're in a separate place, but you have to deal with that. So work through those, check your answers, and then I've put 3 sheets in your lesson email. And they get progressively harder. So yeah, work through those at your own pace, really. I would say sheets 1 and 2 would be good for everybody to do. And if you want a bit of a stretch, then do have a look at sheet 3. So those questions, and then the 3 worksheets in your lesson email.